The purpose of this first module is to set some context as to why we have a company in the first place. Every company exists because it serves some business function or business purpose. And so in order to understand why Rational exists at all, we need to understand what we call the software development opportunity. And so we're going to go all the way back to the very beginning as to what are the characteristics of software itself. And those of you that have listened to Paul Levy talk about software know that he likes to describe it as the pure distillation of human intellect and a way of capturing, human creativity, and the fact that it's this pure essence of human thought. And of course it is all that, but that makes it sound very abstract. We have plenty of chairs, sir, if you'd like to sit down. There's one or two left over, So, software is all of that, but the other thing about software that, it has this duality, which is it really does get work done. And that notion was brought home to me many, many years ago in a machine shop. I went into this machine shop and I saw this numerically controlled drill press. And it was very interesting because there was this piece of work on a jig, and it was being moved around, and every now and then the bit would come down and drill a hole in the work. And what struck me and impressed me about that was that you could completely alter the pattern of holes that was being drilled by just changing the software. You could in fact change the order in which the holes were being drilled or the speed with which they were being drilled, all in software. And further, you could produce hundreds of pieces a day, and they would all be the same. And you could get more throughput, more uniformity, more automation. Now today when we look back on that seems like a very trivial application. But for me, that brought home very viscerally the idea that this software was enabling us to get work done. If we think about some of the technical characteristics of software, one of the things that's been a continuing trend over the last 40 years is that the hardware has gotten much, much cheaper and posed much less of a constraint on our software. I mean, in the early days, programs had to fit into a certain very small memory footprint because memory was very expensive. Memory has now become, a commodity. It's very cheap. Disk space, same thing. Even bandwidth is becoming very cheap. So all of the hardware constraints on software are going away, and this is having the effect of making software larger and, as a result, more complex. Speaking of complexity, we all understand that software is hard to get right. It's one of these interesting things where you not only have to design and architect software correctly at some high level of abstraction, but annoyingly, you have to get all of the details right also. As you all know, it doesn't take very much wrong in a detail to make a software program not work. The level of expectations that people expect from software keeps going up every year. We can see this very, very clearly when we look at user interfaces. You could market software 10 or 15 or 20 years ago with what we would consider today to be very primitive UIs. Over time what happens is people become accustomed to more and more sophistication, and this is a one-way trend. This never goes backwards. You know yourself when you call up a customer service line today and you're talking with the person, you expect that the person at the other end is in front of some sort of computer screen and has access to a database that has all your information in it. You don't even think twice about that. We sort of now take that for granted. That wasn't so commonplace, 10, 15, 20 years ago. And software is becoming omnipresent. I mean, it's in everything that we touch, see, interact with every day. I mean, it's in your cars, it's in telecommunications. The fact that you can make a telephone call any place in the world today from anywhere I can call on my cell phone. In fact, even 10 years ago, I could call on my cell phone and call a colleague in Sweden and get him on his cell phone. I mean, that's kind of amazing when you think about it. We can do that because we have a lot of software in telephone switching systems and elsewhere. An area where software has somewhat silently revolutionized an entire area is medicine. Think about CAT scans. CAT scans are a fairly common diagnostic technique today. Totally impossible without software. All of those images are reconstructed using software. And then in the area of treatment, I have an implanted defibrillator. Okay? So I have a piece of software that monitors my heart 7 by 24. Okay? Now, I'm really interested in that software working. I hope the people that worked on that software did a good job. And I hope before they ship the product, this is embedded software, okay? Truly embedded software. I hope the people that tested that software did a really good job, okay? Because, I'm kind of intimately coupled to that software. So my point is that it's not like software is going to go away, okay? It's becoming more and more integral to our lives every day. Some of the economic and business characteristics, most of you know this, software is very high leverage. By high leverage, we mean for a small change to input, you can have a relatively large change to the output. Sometimes with very small changes to software, you can get a very tremendous increase in functionality. Manufacturing costs are approaching zero. Okay? I mean, today manufacturing costs are basically the cost of burning a CD. And as we distribute software more and more over the web, even those costs are going to go away. But very high R&D costs. And that's represented by all the people sitting in this room. It takes a lot of human effort. Software development is labor intensive. So you have large upfront R&D costs, relatively trivial manufacturing costs. Software is easily duplicated. That's both a blessing and a curse. Okay, it's a blessing because it allows us to distribute software almost instantaneously all over the world. It's a curse because it can be easily duplicated. And so it's hard to protect your intellectual property. It's hard to protect that R&D investment that you've made when someone can just essentially copy the product, the end product. Software is very long-lived, and because of that, it has a very long maintenance tail. And this is something that most of us understand, but very few people that are not in the software business understand. And the most dramatic example we've had of that in recent times has been the Y2K problem. Do you all remember the Y2K problem of a couple of years ago when the world was going to end because all the software was going to die on January 1st? It was very interesting when you sort of drill down on that problem a little bit. The real problem with the Y2K situation was not software that was written in the 80s and 90s. Most of that software was written to accommodate the rollover. The real problem was software that had been written, believe it or not, in the 60s and 70s that was still in service. Now, the people that wrote that software in the 60s and 70s were not stupid. It's not like they couldn't anticipate that the year 2000 was coming. But they made an assumption. They made an assumption that the software that they were writing in the 60s and 70s would no longer be in service by the year 2000. In other words, well, this program won't be running at that time, so I don't have to worry about that. So they didn't program for it. And so almost all of the Y2K scrambling around was because of programs that had been written in the 60s and 70s and were still in service. Most of those programs didn't even run on the original hardware they had been written for. They were running on emulators. And it was a real mess because a lot of the source code for that software had long since been lost. Okay? So that was a real mess. But it was basically a result of the fact that software is very long-lived. Software always lives longer than you think it will. And as I said before, the cost, principally people costs. That's the biggest expense item. So, I don't think I have to convince people in this room that software development is hard. Okay? We might try to analyze a little bit why it's hard. There's a few things that seem to come up pretty systematically. One is just a requirements problem. Requirements seem to be hard to nail down, to make the requirements understood. And software projects tend to suffer from scope creep, scope expansion. As you're building things, people keep adding more things that they want. And sometimes the scope of the project seems to grow faster than your ability to complete it. As a manager, they're very difficult to manage. Part of that has to do with having many different groups that work on software. It's not just the developers. You have analysts, you have testers, you have writers, you have lots of different people. And although we do a pretty good job at Rational of having those people communicate, in many companies, those groups are actually pretty disjoint, and they all talk about the problem using a slightly different language and a slightly different vocabulary, and it's very hard to pull it all together. And as a manager, the feeling that I've had on most projects I've managed is that they always seem like they're right on the edge of being out of control. What is going to go wrong today? There's kind of a feeling of lack of predictability. This leads to loss of sleep, loss of stomach lining, lots of really wonderful things for your health. One of the problems is that our discipline is still very, very immature. I mean, we've only been doing software for 50 years. Think about it. At a similar phase in the evolution of software, of civil engineering, okay, the right angle hadn't been discovered yet. Okay? So we're still early days. The problem is that the hardware that we work on has been evolving very, very rapidly, much more rapidly than our ability to write software for it. Most organizations have very little process. If they do have process, it's not applied very consistently. You go into some organizations and they seem to have no process. You go to some customers and the managers tell you, oh yes, we have this process. Then you talk to the people actually doing the work and they say, well, it's nice that they believe that, but we don't really observe that because it gets in the way of getting our job done. A lot of cynicism about that. There's not much in the way of standards, okay? Not much automation, and a lot of dependence on what I would call gurus. And these are all symptoms of a discipline that is still relatively immature. And I think the last one is the one that gets most people because they don't understand the magnitude of the problem. The software that we build is built up from many, many small pieces, okay? Literally tens of thousands of pieces. And each one of those pieces goes through many different versions as it's developed. And the problem of putting this all together, getting everything with the correct version, okay, so that it all works together, is very, very challenging. And many projects just drown completely in what I would call logistical complexity. Just the problem of putting all the pieces together. So, has Rational learned anything about this? We've been at this for 20 years. You would hope in 20 years we've learned something. And in fact, we actually believe we have learned something about this. The first thing we've learned is that the success rate is not very high. If we take as a metric for success that the project was more or less on time, more or less on budget, and more or less delivered as it was intended, okay, only 1 out of 4 projects is successful. Now, Deanna, if you had to go in tomorrow for an operation and the doctor told you that the chances of success were 1 out of 4, how would you feel about that? Not very good. You know, a 25% success rate in pretty much any area of human endeavor is an embarrassment. Excuse me? Baseball, 250 is okay. Yeah, that's the one notable exception. I still don't believe we should pay 250 hitters $4 million a year, but that's a different story. At any rate, you know, this is an embarrassment, and this has actually gone up. A few years ago, this number was 10%. And we've gotten it all the way up to 25%, and I hope before I die I get to see 50%, because then it's a coin flip, you know. But, you know, that's a pretty sobering notion that by this very simple metric, 3 out of 4 projects fail. The second thing that's very interesting about software is, unlike most other things we do, there are no economies of scale. You know, in most things, when you do more of it, or, you know, things get bigger, you get economies of scale. Software is just the opposite. There are diseconomies of scale. As your software gets bigger, it gets much harder. And this is often the reason why very good software teams fail. Because they've been successful on a certain size project, and as a reward for that success, they get to work on their next project, which is twice as big, which means probably 4 times as hard. Okay? And they face challenges because of that they're just not equipped to handle. So we have a scalability problem in software, and it's a very, very serious problem. Process and tools, one of the things we've learned, certainly through the 80s and 90s, is just throwing tools at the problem doesn't help. Tools are sort of like amplifiers. If you have good people and good process, they will enable those people to go faster and do better. If you have anarchy and you add tools, very often the only result is you get to write a lot of really bad code faster. Okay? So the amplifier effect amplifies not only the signal but also the noise. Okay? So just adding tools doesn't usually help. And, you know, this is because most organizations don't have much process. Despite, you know, a lot of talk about that, most of the companies we go into do not have a process. Or if they do, it's not a good process, or it's not uniformly applied. The other thing we've learned is that taking an organization that's relatively immature from both a process and tools perspective and trying to bring them up the curve is a difficult process, and it takes a long time. It's not something that you change in 3 months or 6 months. It's one of these organizational change things that takes a long time. From an organizational point of view, what we discover is that a lot of the tools groups in our client companies are relatively ineffective. This has to do with the line staff distinction. Most of the projects that are actually doing the software are line organizations. They have budgets and schedules, and the people that are in the software tools groups are usually staff people, and they're usually not very well respected by the people on the line projects. So it's hard for their recommendations to get implemented. Another problem has to do with the way companies do software. They do software with a project orientation. And this causes a real problem, because suppose you're a project manager and I come to you with a new tool or a new process and I say, you know, how would you like to use this on your next project? The savvy project manager will say to me, Joe, that's a wonderful idea. Why don't you go and have him use it on his project first? And when he comes and tells me how wonderful it is, then I'll adopt it. And of course, when I go to ask him to adopt the new tool, he's going to pass me on to somebody else. No one likes to be an early adopter, okay? Because project managers are risk averse, and they don't want to add risk to their projects by adding new tools. Interestingly enough, software development is often not a core competency of companies that develop software, believe it or not. You all have heard of Ford, right? Probably some of you even drive Fords. Do you think there's a lot of software in a Ford? A ton of software in a Ford. Now let me ask you another question. If you went across the country at all of the top universities and top computer science departments at those universities, how many of their new graduates do you think wake up every morning saying, I want to go to work for Ford? Not too many. Okay? They want to go to work for a software company or a computer company. So very often companies that have to develop a lot of software don't have the best and the brightest. Okay? Either at the level of the people developing the software or up their management chain. I mean, if you were to go to the vice president level at Ford, how many software people do you think you'd find? Not many. Maybe not any. Because the people that are going to move up the management chain at Ford are car people. Okay, so a software person going to work at Ford and thinking about his long-term career opportunities, might think about that. And lastly, there's a lot of inertia, resistance to change. NIH means not invented here. A lot of companies are very, slow to adopt things if they didn't think of them first. So we have this interesting problem. Okay? I mean, we have 3 slides. The first slide which says, software is important. Okay? And then we have the second slide that says software development's hard. And then we have the third slide which says, and we know a lot of the reasons why it's hard. Not just technically, but organizationally. So, this is a really bad situation. Because we have this thing that's very important and very hard to do, and yet there's a lot of reasons why, it's not easy to change that situation. So one way to look at it is, we're in a world of hurt. Another way to look at it is, this is a great business opportunity. Okay? Because if we can fulfill this mission of ensuring the success of customers who depend on developing and deploying software, we've got a great business. Why? Well, for 50 years, we've been looking for the silver bullet that makes software development easy. We haven't found it yet. In fact, we don't believe there is a silver bullet. Okay? We believe that there's a way to get better at this, but there's no magic recipe, no magic formula. So if we can be good at this, if we can be the #1 company at doing this, okay, we're going to have as large a market for this for as long as any of us are going to be around. So that's a really, really good situation. And that's why we think we have a great business here. Because from the demand side, demand is going to be strong for the next 20, 30, 40 years, as far out as we can see.